Alright, so in this clip, we'd like to study the attributes of the dynamic simulations. Alright, so till now, we have, create this much amount of the reactions. And as you can see that, the emitter is a point type, or you can say the omni type, but the fluid has been getting, there's a lot of fluid coming out of this. Well, the one reason is, inside the fluid emitter, we do have something called as the max distance, so this is a sample point from which till 1 centimeter the fluid will going to get emitted through all the 360 axis. Okay, so we don't want that much of the fluid, at least for now. So the max distance we could be arranged with zero point 0.2. And now let's just do one thing. First I would like to get rid of with the display the bottom grid. So under the display I would like to take down the boundary draw from bottom to the bounding box. Okay, and let's just play the timeline. So now you can see that it adds some sense, or at least because we are looking actually for the wispy smoke. So wispy smoke is quite a thin, and obviously it also depends upon the type of the source. But in this case I'm looking for, you can say, the tip of the cigarette, or you may could say the tip of the cigar, or you may could say any source which is little small. Okay, so that's pretty much good. And since we have reduced the max distance, what else we could do here is that we can increase the rate percent to, let's say, 250, so that more amount of the density could get added inside this, and that's quite good. We can also play around with the the density per voxel, so I can give 2.5 as the density also, so that we could have some more density inside it, and that's okay, not a problem. But you can see that it isn't looking like that much great or convincing from any perspective. So how are we going to begin with that? Well, first we don't need to use these any of these attributes. We are almost done with the section of the fluid emitter, at least for now. So let's dive into the shape node of the fluids, and first of all we like to work upon the dynamic simulations. Alright, so this is basically controls the overall behavior of the fluids. And this is, here you can see the solver type, which is a Navier-Stokes. We talk about the module 1, and it's the brain of the Maya fluids, in which each and every, you can say, frame of the Maya fluids are getting solved with respect to the scientific equations of the Navier-Stokes. Alright, or you may say the formula of the Navier-Stokes. Well, we do have the gravity here. You can see 9.8 meter per second square. So we would like to tweak the value of the viscosity. Well, most of the people will going to get confused when it comes to the viscosity, because it's actually the liquid property, no doubt, that creates some thickness inside the liquid, a differentiation from water to the honey, all right, to the flow of their two kind of liquids. One is water, another is honey, and of course honey do have a lot of viscosity. So how are we going to fix that thing inside the fluid, which is quite a gas, or you may say we are simulating the smoke, where here in this case the viscosity, if we're going to increase it to, let's say, 0.125, the corresponding voxels of the fluids with respect to the velocities will going to get shared. So if you're going to play, you might not going to notice something, but you can say there's a kind of, you can say, the slowdown. Well, we're going to fix that. It's not a problem. I'm not looking for that kind of, you can say, the reactions. So the most important attributes inside this, you can say, the behavior of the wispy smoke, is the viscosity, which is one of the most important attribute. All right, and now let's just proceed to the high detail solve. Well, the high detail solve works upon the principles in which it tends to preserve or conserve the values of, you can say, the velocity and the mass. So the fluid conservations will going to be a little greater if we don't utilize this. So we could have, you can say, a lot of dissipations of the voxels. So I like to stick to the high detail solve, and like to keep it to all the grids. All right, and we may could use substeps 1 because it's not like that much fast, but I like to give it to the substeps 2. Okay, so for every frame the solver will going to take 2 times of its calculation, so that will going to increase the accuracy, but on the cost of the computation steps. It will take a little longer time, but that's not a problem, because since in the entire scene we are simulating only one effect, so we could increase, we can just break the rules of, you can say, that too important when it's quite a big scene. But for this small scene, we can, increase the values of our solver substeps or the quality a little bit more. So here the solver quality will going to define the more accuracy inside the fluid. So I'm going to take that thing to 250. It's quite a high value. And the grid interpolator has been set to the linear, not the Hermite, and that will take a lot of time to solve. So the start frame is 1, and the simulation rate scale, which is, you can say, overall the speed, or you can say the rate of the reaction. If it's 2, so that means the overall result will be the twice faster. So yeah, for the wispy smoke, I do need to change the attribute from the simulation rate scale 1 to, let's say, 2. And now we are jumping down to, let's keep them on. There's no need to use the forward advection as of for now. We would like to explore the emittance substeps. Let's say we put it on because we have given the substeps 2, so let's emittance substeps as well. And rest we've already utilized the auto resize. Let's just do one thing with these changes. Let's play the timeline. And as you can see that there isn't any something which is great that is happening, so not a problem, we're gonna fix that. So now I'd like to move to the content details, which is one of the most important section of the fluids, because now here you can see that I have bunch of the attributes of the density, and I'd like to explore step by step. So we have the density scale first attribute, which is the uniform, or you can say the universal multiplier for all these attributes listed listed underneath the density scale. So we may could tweak it down to 0.65, let's say, and never give this value of 1. All right. So next property is the buoyancy, which will going to decide the how lighter these fluids are. The higher value will tend to rise upwards. So I'd like to begin with, let's say, 25. And we have the dissipations, which means the naturalistic behavior of the fluids to get diminished, or you can say die off. So I'd like to go with 0.15. And here in this case we don't need any diffusions because this smoke is quite, you can say, the sharp in the nature, very wispy, so the diffusion will going to spoil its properties. So we don't need to use the diffusion. No pressure is required, and even the noise is not required because it's very smooth flow. Now I had a word with you in the previous clip where I talk about the tension. So here are these two attributes which are extremely important to support the naturalistic behavior of the wispy smoke. Without these two, it would be really very difficult to grab the gravity, or you can say the essence of the wispiness inside the smoke. So I'd like to begin with tension, and what this particular attribute will do. The tension tries to create some rounded form of the voxels. So increasing this will tend to destroy the overall reaction. So I recommend to go with 0.025, little less value. You may could work upon tension 4, so let's say 0.1. Okay. And now we like to move to the gradient force. So the density of the, you can say, the voxels increase. It's a kind of you can say the force which increase as the density of the voxels increase. So I'd like to give it, let's say, 10, or maybe let's say 15. I think so 10 should be a good start. So we do have a lot of less resolutions as of for now. So I'd like to crank that thing to at least 80 and just take a look at that, what exactly we have got. So I think so we have just started getting into the kind of a wispy smoke, but I'm not pretty happy. But here we are getting some little kind of a behavior. If you just notice that I mean, there is a moment if you have observed from a chain smoker, it tends to capture this kind of concentric circle, or we can say the circular kind of the details inside the smoke simulations. All right, so I think we should get ourselves done. So I'm taking pause over here, and I'd like to move to the next clip where I would like to address the other two important attributes, that is the velocity as well as the turbulence. All right, so let's move to the next clip.